In this lesson, what we're going to be doing is looking at how we can put together an effect like this. Basically, using some of the volume modeling tools in Houdini to create this sort of strange, diseased morphing head effect. Now, you're thinking to yourself, probably this is something you could do using fields and the volume builder in Cinema 4D, and you wouldn't be wrong. I mean, this isn't that complicated of an effect, but I think that when you're learning how to work in Houdini, it's important to know how these workflows work. Certainly, volume meshing in Houdini is much more in depth than just simply something that we do to SOPs setups like this, but we're going to be meshing liquids and all sorts of stuff later on. So it's just kind of important to get comfortable with that aspect of it. I mean, additionally, we are going to be building a much larger network than we have in any of our previous examples. We're going to actually kind of be going through a whole bunch of it. We're going to be dealing with how to do Voronoi fracture like things, and then we're going to be sending them into a compiled block and a for each loop within that to speed up our workflows. We're going to be dealing with, just processing our geometry in different ways, dealing with groups. Also, we're going to be working with caching our files out and saving them to disk so that they are, efficiently, so we can efficiently move forward through our network without having to wait for things to recook every single time. So I think that this should be fun to kind of pack a whole bunch of information into one lesson. And we won't be handling any of the rendering in this lesson. I think that, at this point, if we were to render every last lesson that we do, it's going to sort of make this course be, orders of magnitude longer than it needs to be. And it already is going to be quite a long course. So I'm going to provide the file with my rendering set up in it if you want to dig into that and look at it a little bit closer. But for our purposes, for this lesson, we're really focused on what we can do with SOPs in this context and sort of the power that's there. And we're going to combine a whole bunch of concepts together. And without further ado, let's let the learning begin. All right, so I've got a new scene here. Let's just go set up our project first. So I'm going to File, let's do Save As. I'm going to navigate to my lesson files, and I'm going to just make a new folder in here. Folder D, I'm just going to save my file here as lesson 03D V01. And we'll call this SOPs. Cool. And we'll hit accept. And to set up my project so that it knows the project directory, I could just use $hip, but just to drive the point home, I'm going to go to Edit Aliases and Variables. In Variables, I've got my job folder, which is set to default at C users mark. I just want to set that to my hip variable. So I'm going to let's just select the hip variable and then grab this string here. I'm going to hit Control C to copy it, go over to the job variable and hit Control V to paste it. So now we can use our job variable in the same way. We could set this to a different location if you want your hip files to be buried inside of a scenes folder. In fact, let's just do that. I'm going to open up my project folder. So I'm going to navigate there. 1 second. So I've got my lesson files here, lesson file D, and let's suppose I actually wanted to save, my project inside of a scenes folder. So we'll have scenes, SCENES, yes, there we go. And then I'm just going to go up here, I'm going to close that, I'm going to hit File, Save As, and then I'm going to save my file in the scenes folder just to demonstrate the difference here. And then I'll just delete this old folder. So we've got our project that's, lesson 03D scenes, and our files inside there. So if I go up to Edit Aliases and Variables again, you can see that my hip file is actually 03D scene/scenes, but I'm going to set my job variable to just 03D like that. a quick way to do this is, if you haven't done this already, grab o3d/scenes and then go down here to your job variable, and then you could paste it and just remove scenes off the end of it. Cool. So we can do that like so. And in this example, we're going to be probably doing a little bit of caching. So it's going to be important to have a project directory that we can start throwing our cache files into, like so. Cool. Next thing, I'm going to change the guides. I'm going to go under, I'm going to hit the D key in the scene view to bring up my display options. I'm going to go to the guides tab, turn off the origin gnomon, go to the background tab, and set the display to dark. Awesome. Cool. So let's start by throwing down a geometry node, and then we can jump inside there. And we'll just start by throwing down a curve. So I'm going to just hit tab over here in the network view and type in curve. And we've got our curve object, but there's no actual curve happening over here. I'm going to select the manipulator, and this here just says left click to add points down at the bottom. So I can do that. I'm just going to create a little, let's just zoom in here and create a little squiggle like so, and hit enter. And it looks like by default it did that in sort of 3D space, which I really don't. I just want this curve to be resting on the ground. So I'm going to undo that by just deleting my curve node here and trying one more time. And let's just switch to the top viewport by hitting spacebar 2. So I'm going to hit spacebar H to home. And I'm just going to draw my little squiggle curve like so. And then hit enter. And then I'm going to hit spacebar 1 to switch back to my scene view. I can, now if I want to do a little bit of adjustment on here, I can grab my manipulator tool on the left, making sure my curve is selected in the node editor, and I can select these different points and just kind of nudge them around. I'm going to switch from a polygon curve to a NURBS curve. You can see that it kind of smooths things out a little bit. I'm going to just kind of move these around till I get sort of whatever random shape, making sure I'm just moving along the ZX plane. And let's just go with something like that for now. Awesome. Now what we can do is let's sweep this. Let's sweep along this so we can create the base of our wall. So let's just throw down a sweep like so. And if we look, it's got these required inputs, hence these red triangles. So in the first input, we've got the cross section, and in the second input, we've got the backbone. It looks like our curve is going to be appropriate for our backbone, so that's good. Obviously, we need a line to go in there as well. So I'm just going to throw down a line. And I want the line to go in the positive Z direction. So I'm going to put in 0 in the Y direction and 1 in the Z direction. And I'm just going to wire that in. And now you can see that it is sweeping our line along this curve, but it's only using those 4 control points that we had because it's a NURB. So I'm going to resample this. And resample will just take any input curve, and if I turn points mode on, you can see I've got these NURBS handles out here, those control points. If I throw down a resample and turn the display flag on here, you can see that it has resampled it. I'm just going to hit the D key real quick and go to my guides, and I'm just going to increase my point marker size to make it a little bit more obvious. You can see that now we've gone from having these 5 control points to now a polygonal curve where each one of these is a primitive, and it's got a a point along each one of these primitives. You can see that the length is set here in this resample. If I change that length, we get more points. I'm decreasing it, we get more points. If I increase it, we get less. So let's just keep it at something like 0.1, which is the default. And now let's check our sweep. You can see that it is sweeping our line along this curve. I think that our line is actually pointing in the wrong direction. So if I select our line here, and you can see I got this nice rotate handle, it looks like it wants to be, yeah, it looks like it wants to be pointing along if I look up here, you can see that when I change this direction, like so, that it's actually adjusting this vector here. So it looks like I was wrong. I actually want to point this along the X direction, which keeps it perpendicular to our curve, which is here. But we want our, first off, our line is way too big, so I'm just going to take the length of it down. And then we actually want our line to be centered on this curve. So we can do the old copy relative reference trick that we used before to stick a box on the floor. I can just grab this length, and I'll hit copy parameter, then in direction, instead of, then in the origin, since we're displacing it along the X direction, I'm just gonna, right here where in the X field of the origin, I'm gonna right click and say paste relative reference, and that offsets it by its length. We actually want to offset it in the negative direction by half of its length so that it is centered on this curve. And you can see that if I change the length of it now, it's perfectly centered about that curve that we gave it. So cool. Now on the sweep, I'll just go and select on the output, we're going to just skin unclosed. And so now it's created a nice poly strip for us, like so. Cool. Then the next step to turn this from the profile of a floor into an actual wall, I'll just throw it on a poly extrude. So poly extrude, and let's just wire that in. I'll grab the my manipulator is selected. I've got this red line. I can just drag that up a little bit, maybe like that. We'll do that for our wall. I'm going to turn off points mode. Don't need to see that for right now. Important note about the default settings of the poly extrude is that it doesn't output a back. So you can see here it's just this open hole underneath the wall. And I'll just scroll down in my parameters on the poly extrude node and just tick output back. And that just makes it a nice solid piece of geo. Cool. So now what we can do is let's just throw it on a null just so that we can keep track of what we're doing. And we're just going to call this the base wall shape. Base shape. Base shape of an object that we want to turn into a wall. Cool. So now, in order to get a wall, we want, little rock chunks out of all this. We want to turn this into a bunch of little chunks that look like rocks. So one way we can do that is using Voronoi. So I'm going to do, I'm going to throw down a Voronoi fracture. And you can see if I wire into this and click this node, it's throwing an error because it's expecting that we provide it points. So I could, create some points by throwing down a scatter. So I'm going to scatter, let's say 100 points. And it's scattering only around the edges, the surface. If I show the base shape like so, oops, wire that back in. If I hit my display flag on the base shape and then come down here to the scatter and hit the template flag, it's kind of hard to see. I'm just going to hit W to go into wireframe mode. You can see it's only scattering on the surface of this wall. So when I wire that into the Voronoi cells, we get this, or into the Voronoi fracture, we get this, and hit W so that we can actually see what we're looking at here. Smooth wire shaded mode, and set the display flag to the Voronoi fracture. You can see we've got our Voronoi fracture occurring with these fracture points along the surface. Now, another way to help visualize this, I can throw down an exploded view. And I like to, when I'm doing stuff like this, I like to keep the exploded view sort of off to the side so I can keep referencing what my pieces are looking like. So it's just, the exploded view just takes the name attribute that was created by the Voronoi fracture and uses it to extrude. We haven't really talked about attributes yet, but we will in a later lesson. So here's a pretty good preview of what our Voronoi fracture is looking. For good measure, I actually like to scatter throughout the object, not just on the surface of it. So if I throw down an ISO offset here, and I'm just gonna wire in the base shape of our wall into the ISO offset, you can see that the ISO offset is trying to create a volume. And if I change up the uniform sampling divisions to like some larger number like 50, and then we wire our scatter into it like so, and I'll display the scatter, you can see it's going to scatter. It's scattering throughout, but because we have relax iterations on, it's actually trying to push the particles apart from being truly random. So now if I turn relax iterations off, it's no longer trying so hard to push the particles away from one another, but just letting them randomly appear wherever they are inside of our object. So now if I go back to the exploded view, you can see we get some pieces that are, and it's kind of hard to tell in this example, but we get sort of more of a random distribution of pieces. We've got sort of a smaller one here. It looks like this one's originating from inside the center of our object and so forth. So that's just another way that we can throw down our fracture, our scatter points for our fracture. So now that we've got our Voronoi pieces, I think it would be really great if they were all, a little bit smoother. So maybe we could do some volume modeling on these and get them to be smoother, more like rocks that have been worn down in time. So if I throw down this is where we can start to do more volume modeling stuff, like the volume builder that we have in Cinema. So if I throw down a VDB from polygons, a VDB from polygons will convert this geometry into a volume object. I'm just going to take the voxel size down to something like 0.01 just so we have a little bit more resolution. Cool. And you can kind of see the cracks are appearing around the edges here. Now you might think at this point I could just start smoothing this out to see if it gets rounded. So I'm going to try to do that. Oops, not using a smooth node. I'm actually going to hit tab and type VDB smooth, and we're going to be doing VDB smooth SDF, because that's what we're working with right here. And SDF is a sign distance field, and that by default is what is set on the VDB from polygons node. So we've got our voxel size, which is, literally just taking the volumetric area of this and dividing it up into little tiny cubes that are this size in world space units. So we've got a bunch of little tiny cubes inside of here that are determining what the volume of this object is and where that object exists in space. A sign distance field will let you, sort of determine where the surface of that object is in terms of negative and positive values. So in the case of, VDBs, outside of the object is a positive number and inside of the object is a negative number. Or it's the other way around. I can't really remember. But in here, when we've got these interior and exterior band voxels, that just determines how far outside the object we're going to store extra information about its distance to the surface. So I know that that's like probably more information than we really need at this point, but that's what VDB from polygons is doing. We could make a fog VDB instead by unchecking the distance VDB and checking fog VDB. And you can see that it's done something similar to what ISO offset did, which was creating a volume out of the object. And you can almost see our Voronoi pattern sort of distributed throughout the density of this fog. Switching it back to sign distance field, this distance VDB creates our surface. Now we've got our VDB represented as an SDF, and we can use the VDB smooth SDF node to smooth it out. But so if I select this node and I start messing around with these iterations, the more smoothing iterations I have, the smoother it gets. And if I change this radius, the filter radius, to go up, you can see that it gets much smoother as well. So these sort of controls will allow you to kind of smooth your geometry out. But we're trying to smooth out individual rocks, and this is sort of an issue because we're just smoothing out the entire wall. I mean, we can barely make out any of these rock shapes that we had created here. And this is where the for each loop comes into play. for each loop can look at a piece of geometry like this and determine from it what each, can run over each piece individually. So instead of smoothing this entire wall, we could just smooth one rock at a time. And we're going to do that. So to illustrate this, I'm just going to hit tab and type for each. And I'm going to choose this first option. There's a few other options, but for right now, all we're going to worry about is this for each connected piece. So I'm going to click that and drop that into our network. And it creates this thing. It's got 3 nodes here and then this orange blob surrounding 2 of them. So let's just talk about these really quickly. Connectivity. What connectivity is going to do is it's going to analyze this geometry and determine what pieces are connected to themselves. So, by default, if I go through here and I select a polygon, it's just selecting one polygon. If I go up here and select 3D connected geometry, it's actually detecting full pieces of geometry. Now, just based off of like how the polygons and points are all connected to each other in the data of this setup. So similar to how this works, when I'm trying to select connected geometry, that's what the connectivity SOP can do. It will actually create an attribute that can be read by the for each loop to determine if the piece is connected and then iterate over it. So let's just wire in our Voronoi, the output of our Voronoi into this connectivity and click it. And you can see like literally nothing happens. It's just looking for primitive connectivity and creating a class attribute for us. And by default, because, when we throw down that this particular setup from our tab menu, this for each block knows to look for the primitive class piece attribute that was created by the connectivity. So if I go to the end here, you can see really nothing has happened. But what it's doing is it's going through and saying anything between these 2 blocks, because we have a block begin and a block end. This block end is just referencing this block begin right here is just referencing this block end, and they're tied to one another by these parameters. Basically, what it's saying is for every piece that you detected was connected up here, run through and do whatever's inside of this orange part to each piece. And you can see over here in our network view, there's a little piece of information here. You can see piece 99 and then gather 100. That has to do with the fact that there's 100 pieces here, because Voronoi, we scattered 100 points. So it's working. It's detecting that we've got all these pieces. So if I go to this bottom node, I can actually bypass it compiling and merging all of this information together and just select a single pass. So I'm just going to tick this box right here that says single pass. And you can see if I scroll through and change which pass I'm looking at, I can look at an individual piece. So now let's just work on this piece, for example. If I were to take this smoothing operation that we were working on over here, I'm just going to shake this to disconnect it from that other network that it was connected to, and I'm just going to drop this in here. Now you can see, if I highlight the end of my for each loop, that we are actually smoothing one of these pieces. So I can try and, let's go through here and try and just find a setting that we like that makes something look nice and round like a rock. Like how about something like that. I'm doing a filter radius of 3 and iterations of 5, and that kind of creates what might be passable as a rock shape. We're just going for something smoother at this point. So if I go back to the end here, instead of ticking single pass, I'm just going to uncheck it. And it's running through, you can see down here, it's running through 100 passes and doing that for every single piece that's in there. Now, some of my rocks are super small and they're becoming like almost little drops. I think that might be a little bit too extreme for the smoothing, so I'm just going to dial it back a little bit. Maybe decrease the filter radius. And there you go. So now we kind of have a bunch of little smoothed out rocks kind of all packed into a tight area that is, was representative of those Voronoi cells that we created. Because this is all a surface, it's still spitting out an SDF. Now, if I just convert that back, I'm just going to throw down a convert. Oops, sorry, a convert VDB. And we're going to drop that right here. It's going to think about it for a second. And now, so convert VDB by default is just going to convert it to another volume. I'm just going to say convert it back to polygons. So now it's not going to be a surface anymore, but it's actually going to be polygons. You can see it's actually created all of those polyfaces for us. So it's gone through and converted each one by one back to a piece of geometry. So if we wanted to, suppose we wanted to like get a little bit more character to these rocks, we could add some noise pattern to them. So I'm going to just turn this back to single pass so I don't have to wait for it to go through all the iterations of this loop to get some feedback. I'm going to select, let's just select any old rock in the middle here, like this one. And I'm just going to add some, I'm just going to add a mountain to this. And see if I can get sort of a craggly rocking looking thing. Now, I think that it's got way too much, it's way too aggressive. So I'm going to just bring the height back down and maybe decrease the element size to something that looks a little bit more, more on the rocky side. Maybe something like that's good. I don't know if I really need all this roughness and this noise. Maybe something like that is good. And then let's go back up here to maybe bring the height back down a little bit. Looks like the height's still pretty intense. Maybe I got to bring the height, the element size down even further, like so. And I'm just gonna middle mouse drag on the height, just bring it back, like so. So now we have something that looks a little bit more gnarled up, like a rock. So now if I go to the end of my for each and untick single pass, it's going to run through the loop again and create a bunch of rocky looking stuff here. And like even at this point, I'm thinking that this noise is a little too intense. So I'm just going to go back here. And I think it's a little bit too high frequency. I'm just going to maybe double the element size, which is the size of the noise element. Let's make it 0.2. Let's run through the loop. And there. I mean, we've added a little bit of variation, not too much. Maybe I'll just crank up the height to something like 0.08. I made a mistake here. So it doesn't know what to do here. I'm just going to right click and say delete channels. And it's, you know, you can see it has to cook through this for each loop every time I do anything. So I'm just going to go down here to auto update and click manual mode. And that can prevent that, so you can go make changes. And we'll just do 0.08 like so. You can see that it didn't actually do anything. It's a great way to restrict Houdini from doing things without your permission, is to turn this into manual mode, and then I can manually update that by hitting this little looks like a recycling icon. So cool. So now it looks like we've got a little bit of variation to our rocks, and I'm just going to turn on smooth shaded mode. So it looks like we have a little bit of variation to our rocks. They're not like perfect, perfectly smooth VDBs, but they've got a little bit of bumpiness to them. Cool. So at this point, I could just throw down a null, and I could call this. This is our rocks. These are our rocks. So if we're ever going to do anything else and we wanted to reference our rocks, we could do that. And now, you know, everything is disappeared, and that's because I'm still in manual mode. And since we're kind of done working with this loop, I'm just going to go down here and click manual and switch it back to auto update, and we're back to our normal behavior. Awesome. So now let's come up with a strategy about how we're going to fill in the grout between these rocks. So I'm going to go and say what we can do is use our volume modeling tools to perform sort of a Boolean operation and carve out a hole in like the base wall geometry based off of all these rocks. So let's do that. So I'm going to go back up and reference my base wall shape here. I'm just going to organize these nodes a little bit better. Just going to drag that over. Yeah. something like, whoops. If Houdini ever starts cooking and does something that you don't want it to do, you can see down here, if you click escape a bunch of times, it'll stop doing it. So suppose I've got this and it's starting to cook and I don't want it to, and I just tap escape a bunch of times, it stops, and then you get a bunch of errors and they'll say, you know, cooking was interrupted. That's because I told it to stop calculating. And you know, when you get a really heavy scene, sometimes you're gonna want to like execute, you're gonna want to like stop Houdini from doing what it's doing. Because maybe you clicked on the display flag on an unintended node and it's starting to cook and you're just like, no, I don't need that. So that's what the escape key is for. So up here, I'm going to grab another, I'm going to click on the bottom of the base shape node, since we're going to reference this geometry for our wall, and create another VDB. So I'm just going to, let's just drag these guys down a little bit, and over here, I'm going to drag off to the side. I'm going to option click to create a little knot, and then I'm going to come down here like so, just so that we're sort of near where we're, oops, I'm going to grab this knot again, come down here, just so that we're sort of near where we are over with this stream on the left-hand side, and I'm going to throw down another VDB from polygons. So with that string attached, I'm going to hit tab and then do VDB from polygons. Awesome. So you can see now that it creates a pretty coarse VDB. I'm going to just set the voxel size of this to something like 0.01 again, which is close to what we had over here. I could tie these together using edit parameter interface, or sorry, I could tie these together using relative references, which I'll do now, because we're going to actually need to reconvert this back into another VDB to get it to you know, Boolean with this object. So what I can do is, let's just create another VDB from polygons. I'm just gonna alt drag this over here and wire it into our rocks. So now we've converted our rocks back into a VDB. And I'm gonna just go up here in the voxel size. I'm gonna right click it, copy the parameter. I'm gonna select this other VDB from polygons, and I'm going to select all of this. I'm going to select this value here, right click and paste relative reference. And if there's like any extra decimals at the end here, like sometimes that happens when you are pasting relative reference, like I got a 1 here, I'm just going to select that, delete it, hit enter. So now if I click on voxel size, it's going to be 0.01. If I go over here and change this voxel size to maybe 0.05, you can see it changes this geo. And also if I go over to this one, you can see that this is updated to 0.05 as well. I'm going to just, you know, I think this works both ways. So if I actually go over here to, you know, not this expression, but if I click on this so I can see 0.05, I can change this back to something like, let's do 0.005. And it will update this value. And also it'll go backwards and update this value, which is actually the driver. So really both of them can drive. But I mean, if you were doing any animation, you definitely would have to do it on this node. Cool. So the next thing I want to do is let's do a little bit of let's smooth this out a little bit. So I'm going to throw down a VDB smooth, and let's just drop that in here. Wire in that. Let's just leave it at 1 maybe and crank up the iterations. No, I'm going to have to put the filter voxel radius to 2, and we'll do 5 iterations. That makes it a little bit smoother around the edges. And then what we can do is we can do a VDB combine to get the to do sort of a Boolean operation. So let's throw that down. VDB combine will, let's just wire in our rocks on the left and our wall on the right. So what VDB combine will do is, by default, it's just, it's not really doing anything. It's just copying the first input onto itself. But under this operation drop-down menu, you can select all these different options. And for us, we are working with signed distance fields. We want to do SDF difference. You can see what that has done is it's taken the wall over here and subtracted it from all these rocks. We actually want it the other way around. So what we want to do is we actually want to subtract the rocks from the wall. So if I'm on this node, I could just rewire this so that the inputs are reversed. Or if I select this node and hit Shift R, it swaps those inputs, and you can see that these are now crisscrossed. Cool. So now it's taking whatever's in. It's saying whatever geometry is coming in the left, whatever sign distance field is coming in the left. I want you to take that and subtract from it whatever field is coming in from the right. So you're left with this sort of an object, and you can see that like it looks like there are little hollow chunks in there in the shape of our rocks. So I'm gonna go on and let's throw a let's reshape this, because it looks like this is actually a little bit too close to the surface for it to really be anything that looks like grout. So let's do a VDB reshape. So I'm going to start typing reshape. You can see I get this VDB reshape SCF node. If I throw that down on our wall, I can actually use it to erode our wall a little bit. Now by default, it's set to dilate. Dilate will just cause this VDB to grow as we crank up this offset, but we want to actually set it to erode. And as we crank up this offset, you can see that it actually shrinks basically almost like along the normal vector of this piece of geo. It just shrinks it. So let's try something like 2 and then go back to our VDB combine. I got to make sure that this is wired in right here, so I'm just going to drag that guy down. You can see that now we're starting to get more pronounced holes where our rocks were. So if I go over here and I continue to crank up this offset, you can see it really chewing into this this right-hand side VDB and giving us more defined details here. I'm going to just bring it back to something like 2, because I think that once we apply some smoothing, these thin areas are going to thin out a bit too. So let's go over here and throw down a VDB smooth SDF again, and we're going to smooth this volume out and see what we're left with. And you can see, yeah, we're starting to get some more nice edges here and just some stuff that looks a little bit more like grout. Let's just turn up. Let's see. I'm just experimenting right now by changing the voxel radius. I think that's taking away a little bit too much detail. If I leave it here and maybe change the iterations up a little bit, that seems like it's doing a pretty good job for right now. Let's for the time being, let's just convert this back to a let's convert it back to a polygon and then merge it with the original rock geometry to see where we're at. So I'm just gonna hit tab and then say convert VDB again, and here we've got we're just gonna convert it back to polygons. So I'll select polygons from that menu, and I'll just wire this in here, and now we have we actually have polygonal geometry. Now I can name this the grout. So let's throw down a null and wire that in, and let's call this capital grout. So I'm just gonna using this middle bar and this up arrow to the left, I'm just gonna collapse this up so I get a better view of my network. This is taking up a lot of space. I'm just gonna I'm just gonna go to the left here so I can see this little up arrow, and I'm gonna collapse that parameters view up. And then if I hit the P key, it brings up another parameter view off to the side. And you can see if I select my nodes, I got my parameter view just tucked in the corner over there. Just gonna bring this out a little bit, and then we can zoom out. And you can see we've got our grout here and our rocks. So I can just select both of these, hit tab, type in merge, and just selecting those didn't do anything. If I select this and this, but now drag down to the merge, it's going to put our rocks and our grout together. Cool. So this kind of looks like a rock wall. I'm thinking like I've got issues with some of these sections are looking like way too thick, but we're getting there, you know. And this is kind of it. We've done some like, you know, some volume modeling to like get this put together. I think that what we did with the Voronoi may have been a little bit too erratic. So we're getting sort of these shapes that are kind of intersecting with one another. Same with the noise. So let's just see if we can go and refine this a little bit. I'm going to go back up to the Voronoi. And in the scatter, I'm going to just let it do its relaxation thing, just so we can get a little bit more consistent sized pieces. So let's just turn on relax iterations and see what that does for us. You can see it's going through the loop, thinking about it, converting from polygons, and creating our grout, and our shapes have changed a little bit. I want to revisit our original... I just want to revisit our original, the creation of our original rocks, because I can see like it looks like it's just a little bit too uneven. So let's go back up here to our for each end, and I just want to mess with this, maybe mess with this noise pattern a little bit. Yeah, just gonna do that. So let's I'm just gonna pick a single pass like this one, and I'm gonna let's bring down the let's turn up the or let's bring down the smoothing a little bit. I'm going to turn off the mountain just so I can see what my base shape of my my geometry is. Let's see. So we got iterations like that. Let's just go. Yeah, let's try something like a little bit more pronounced, and then see what a noise will do to that. Okay. Let's just turn off single pass on the for each end and see what our gaps look like. Because really what I'm doing right now is I'm trying to modify how thick of gaps we're getting in between our geo. That's looking a little bit too Voronoi to me, so I'm going to just backpedal a little bit and get this smoothing back in order. Maybe we'll go to a filter voxel of 3. Okay, so now we're getting a little bit more there. In our mountain, let's just bring the height of this down. I'm gonna go back, selecting our for each end, and select single pass. And this is sort of what my workflow will be if I'm working with a for each loop like this. Is I will continuously go back and forth between single pass so I can get a quick iteration of one of the loops out, and then try to and then I'll switch single pass off to see what the overall effect of it is. Maybe let's just smooth this a little bit more. Let's do a radius of 4 and maybe 4 and 4. 4 filter voxel radius, and then 4 iterations of smoothing. And I'm gonna go back over here to the for each end and untick single pass, and look at our results. And those look like a bunch of rocks. They're very scattered from one another. So maybe what I'll do is a reshape in here. So I'm going to throw down another VDB reshape SDF, and I'm just going to drop that in the middle of the mix. And it's cooking here, and you can see I've dilated each one of these rocks just a little bit. You know, what I'm thinking too here is, because it looks like we've got this small rock on the surface, I might actually want to scatter only on the surfaces so I don't get so many cell points inside of my wall. So I'm actually going to just turn off the ISO offset so that our scatter goes from being, you know, sort of scattered throughout this volume to being scattered only on the surface, and see what kind of effect that has. Let's go back down here and select our rocks. And it thinks through the loop. And almost, I feel like that's actually helping these rocks feel a little bit more consistent with one another. Yeah. Cool. Let's also scatter more points. Let's do 150. See if that does anything. Cool. I think like another thing that I would try at this point also is, I'm thinking my gut is telling me that we could go for a little bit higher res on our initial VDB. So I'm gonna just let's just drop this down in half. So we're at 0.01. I'm gonna go to 0.05 and see what that does. And this should have a dramatically different effect because the smoothing levels are gonna change as in terms of how many voxel radiuses it's messing with when it does the smooth. So you can see that it fills everything in quite a bit more. So I'm going to just mess with our smoothing settings a little bit more. Let's go back to our for each end. I'm going to tick single pass, find a good rock in the middle here. Cool. And let's turn off the mountain for right now. I'm going to turn off the reshape for right now by hitting these little yellow flags on the left-hand side. And I'm going to just mess around with the smoother a little bit more. Let's just turn the radius up to 5 and maybe do something like 5 filter voxel radius and 5 iterations. And let's go back to our for each end and untick single pass and see how that lands us. You can see it thinking through all those loops. Yeah, I'm really feeling like this spacing is getting a lot better. We're getting a lot tighter little areas between these rocks, and it's feeling a lot more like some reasonable grout could fit in there. So let's just reintroduce. See, I'm not even using the reshape at this point. I don't think we're going to need it. So I'm just going to go back to the mountain. I'm going to turn the mountain back on just to get a little bit of noise variation in our rocks to make them look more rock-like. And it's thinking through the loop. Cool. So now we've got a little bit more movement in our rocks. And I think, you know, honestly, one more time, I'm going to switch back to single pass mode. I'm going to go to our mountain node, and I'm going to adjust this noise just a little bit more. So here, our height is 0.08. I'm thinking that might be a little bit too much even still. So I'm going to bring it down to 0.05. I'm going to decrease the element size so that this gets a little bit rougher. You know, a little bit more coarse. And I think that even the height size could come down even just ever so slightly more. And then I'm just going to bring my roughness up a little bit just to get that kind of roughened rock look. So yeah, with something like that, I've got like a height of 0.33. Now all of this is going to depend on what your scene scale is. I'm working here. If I go back to my original curve, I'm working in roughly, it looks like about, you know, I've got 1 to -1 here. So my wall is like roughly, you know, 2.5 to 3 meters long and maybe 1 meter tall, if I had to guess. So, you know, depending, if you're working with a wall that's hundreds of meters long, you're not going to want to work with a filter voxel or with a voxel size of 0.005. It's going to be way too high res. So just something to keep in mind when you're doing volume modeling is what kind of what scale you're operating with your actual base geometry. Coming back to the for each end here, I'm going to untick single pass one more time and see what we're left with. And it's thinking through that loop. You can see down in the lower left-hand corner here, and we got a whole bunch of rocks. Cool. Now let's see how this plays with our grout. So I'm just going to pop down to our grout and check out what that looks like. You can see now it's cutting out some interesting, nice, much more even patterns in this grout material. Let's combine them together. Cool. Yeah, I think that maybe after I convert this VDB of the grout back, I might add some noise over here as well. So let's throw it on a mountain. You can see that mountain's crazy right now. I'm gonna just decrease the height of that. And I'm going to just choose, instead of hybrid terrain, I'm going to choose standard. It's just a standard fractal for the fractal that's in our noise. Our element size is way too large. I'm just going to middle mouse click on, well, let's just bring it down to 0.01 to see what that gives us. Yeah, that's way too small. But it gives us a good idea of what height we're working with. So I'm just going to middle mouse on the height. I'm going to go start scaling it down on levels of 100th and into something like that. Then I'm going to middle mouse on the element size, start bringing that up until I get something that looks a little bit more organic than what we currently have. Something like that. It's just a little bit gnarled up. and merge them together. And here we have what looks like a nice little stone wall. We got rocks. Looks like somebody randomly, placed whatever rocks would fit in there, mortared them together, and and there you go. So now what's like a cool thing is we could go all the way back up here to the top, and I could, put this back into manual mode, grab my curve, and I'm going to grab the manipulator of my curve, and let's also set the display flag up here. I'm actually going to untick manual and go back to auto update. I can now just move any one of these points around like so. Maybe do something like that. Now this is going up in the air. I'm just going to snap it back to the grid by going like that. So now we've changed the shape of our wall. So maybe grab this point and move it over here. Or in fact, you know what? Let's just throw down a circle and make a circular, almost like the opening of a well. Let's do that. So now I've got a circle here. I'm going to just set my circle to be on the ZX plane, and let's just scale it down a little bit. Maybe 0.7 seems good. And then instead of wiring our curve into the resample, I'm just going to wire the circle into the resample. Now, if I look at this, you can see if I turn on points mode, I've got all these points around the circle. And if I run the sweep, it looks like it's making it all the way around except for this little area right here. Let's do skin with auto closure instead of skin unclosed on the sweep. That just allows it to close out our sweep geo. And now if I jump all the way back down to the bottom, and let's just throw it on a null to signify that this is our wall. And it will think through that loop. It'll extrude our geometry for us based off of that input circle. And we should get a very similar looking wall, but it's in a totally different shape. Smoothing, and it's doing all these operations. And if I select this null now, you can see if I turn off points mode, we've got a wall in the shape of a circle. Cool. So you can see it's super flexible to create tools like this where you could run through a whole list of geometry, throwing different shapes at this thing to get walls built in any which way that you would want. Cool. So now that we did that, let's just go back and kind of try and see what other kind of cool things we can do with this experiment.